Welcome. This is Odumat. Today I want us to look at bearings, and then we are concentrating on back bearing. Back bearing. What's a back bearing? I was teaching in a class and asked this question about back bearing. Somebody said, when you walk back, please, it is not so. It is not so. Back bearing is just, let's say we moved from this point to this point in this direction. So from this point to this point measures theta degrees. Now the back bearing of this is now, so the direction was from this point to this point. Let me call this point A and this point B. So when you are coming from B back to A, that is about back bearing. So that is going to measure from this point up to where we have. So that is going to be the theta plus this 180. So I'll talk about how we are going to get those angles. But before then, I want to clean this and then remind ourselves on properties of parallel lines. We did this some time ago. Properties of parallel lines. So let's go through that and then come back to back bearings. Okay. Now let's look at these lines. So line AB and line CD are parallel lines. Parallel in the sense that they will never meet, and the distance between the starting points, between them at the starting point, will be the same as the terminal point where they are going to end. So the distance from this point to this point is the same as from this point to this point, and all the points along the line. Okay. Now, if these two lines are parallel and line EF is crossing them in this manner, then line EF is called the transverse or the transversal line. So this is given as a transverse. Now let's see. This angle I've marked here is called the alternate angles. So angle A and B, A is equal to B. That is alternate angles. Alternate angles. I'm just making some inscriptions here. So line A, so angle A and B are alternates. So the same way, this angle and this angle is also alternates. Okay. So maybe let me add more. If I am to put another angle C here, A is vertically opposite to C. If I am to put another angle here, then D is vertically opposite to B. Okay. And then if I am to put another angle and call it X and this Y, so X and then Y are corresponding angles. Please, maybe we'll do this later in another lesson. Okay, but for the sake of back bearing, let's concentrate on angle A and then that of B. So these two angles are alternate angles. Okay, now let's go back to the back bearing issue and see how we can use this idea here to learn about back bearings and then solve examples as well. Okay, now if theta is an angle less than 180 degrees. This is A to B. So if this is theta, geographic north, we shouldn't forget this. So this is point B, this is A. Now, if the bearing of B from A is theta, the bearing of B from A, in the sense that we are moving from A to B in the direction from this point to that point. So we move from geographic north clockwise direction to this direction, this line, and this line measures from this point or goes straight to B. So from here to here measures theta. Okay, because I said bearings are measured from geographic north in clockwise direction. Okay. Now, so if the bearing of B from A is theta, then the bearing of A from B, that is the back bearing. Okay, now let's see. The angle here is less than 180. This theta angle here is less than 180. So it means that the back bearing, we need to add 180. The back bearing, we need to add 180. So the bearing of, let's say if the bearing of B from A is theta degrees, then the bearing of A from B is going to be theta plus 180 degrees. Theta plus 180 degrees. Now, let's use the idea of the parallel lines we talked about. So let me continue this and then continue this one. Okay, now the angle here and this one are alternate angles. So let me call this angle beta and this angle also, since they are the same, I'm going to call it beta. Okay, so the angle here and this one too are also the same. So this angle is also theta. Okay, now from here to here measures theta degrees. Then we are moving back. So that is going to be from this point to this point plus this angle. So that is why I had theta plus 180. From this point to this point is 90, to this point is 180. So from this point, angles on a straight line measures 180 degrees. So from here to here is 180 plus the theta we covered already. So if the bearing of B from A is theta degrees, then the bearing of A from B, we are coming back. That is going to be 180 plus theta, or theta plus 180, and addition is quantitative. So 180 plus theta and theta plus 180 is the same. Okay, so that's all about back bearing. So here I said if the angle is less than 180, we add 180. Let's look at when it is more than 180. What happens? Okay, now we are moving from B to A. We are moving from B to A. So the bearing of, let's say if the bearing of A from B means that we are moving from B to A. Okay, so if the bearing of A from B is theta degrees, and this theta here is more than 180. So from here to here is 180 plus this one. So this is more than 180. If it's more than 180, then we take 180 from the original angle given. Okay, if the bearing of A from B is theta, and we know that theta is greater than 180 degrees. So in this sense, we need to subtract 180 from the angle to get the back bearing of B from A. Then the bearing of B from A is, so that is going to be theta minus 180 degrees, because theta is greater than 180. So we subtract 180 from the angle. So like I said, if theta is equal to 180, what's its back bearing? So that is going to be, we either add 180 or subtract, whichever way we get the answer. If it is exactly 180, we add 180 or subtract 180, and that will give us the exact answer. Okay, so let's say the bearing of B from A is 180. What's the bearing of A from B? It's 180 minus 180, or 180 plus 180, and we'll still land at the same answer. Okay, so because we said 360 degrees is the same as 000 degrees in bearing. Okay, so let's look at these two examples. The first one, if the bearing of Q from P is 43 degrees, find the bearing of P from Q. Then the second one, if the bearing of B from A is 279 degrees, find the bearing of A from B. Okay, so let me write the answers just here. Now I said if the answer and the bearing given is less than 180, we add 180. So here the answer to this becomes 43 plus 180 degrees, and that is going to give us 223 degrees. So the second one, if the bearing of B from A is 279 degrees, find the bearing of A from B. So I said if it is more than 180, we subtract 180 from this. So this is going to be 2, that is the solution. It's going to be 279 degrees minus 180 degrees, and that is going to give us 99 degrees. Okay, so now let's look at this example. The point P is 3 kilometers due east of the point Q. If R is 4 kilometers due south of Q, find the bearing and distance of P from R. Okay, so the point P is 3 kilometers due east. Now let's draw the diagram. So the point P is 3 kilometers due east of the point Q. Okay, so this is the point Q, and this is 3 kilometers. So this is the point Q, 3 kilometers, and this here we go to P. So P is 3 kilometers east of Kyo, and this is Kyo, so this is the eastern side of Kyo. Okay, so and R is 4 kilometers due south of Kyo. So here we go southward 4 kilometers. Okay, so this is R, and then we are asked to find the bearing and distance of P from R. P from R means that we join those 2 points and then find this angle. Let me call this angle theta. Okay, now this is exactly right angle triangle. So we have 90 degrees here, and then this side measures 3 kilometers. So we can look at this and look at the Pythagorean triplets. That is 3, 4, 5. So here we definitely 5. But let's see. So let's go by, let me call this side x, and let's go by the Pythagoras theorem. So for Pythagoras theorem, the line PR, so PR squared is equal to QP, so QP squared plus QR squared. QR squared. Okay. So this symbol means the absolutes, that is the distance symbol. Okay. So the point, the line PR, we don't know. So that is what we marked x. So x squared is equal to QP is 3 kilometers. So that is 3 squared plus QR is also 4 kilometers. So 4 squared. So x squared becomes 9 plus 16. So that is, this is 9, this is 16. Okay. So x squared becomes, this and this will give us 25. Okay. Then x becomes, that is putting square roots on both sides. So since it is distance, we are going to ignore the negative aspects. So this is going to give us 5 kilometers. Okay. So now we talk about the bearing. Okay. Let's talk about the bearing. That's the direction of P from R. P from R. So this is the angle. Okay. Now we can go by the tan. Or since we know this to be, we can use any of the trig ratios. We've learned trigonometry some time ago. Okay. So let me use tan. So from here, this is opposite. This is adjacent. So tan theta is equal to, opposite is 3 over adjacent 4. Okay. So this is, we are finding the angle. So theta is equal to tan inverse of, this is going to give me 0.75. So tan inverse of 0.75 becomes 36.869 degrees. So we can say that theta is approximately 37 degrees. Okay. So therefore, then we are not done with the answer. So therefore, the bearing of P from R. So P from R is 037 degrees. Please, this is very, very important. This answer is very, very important. Then we talk about the distance. So the distance is 5 kilometers. The bearing is 037 degrees. Let's get another example and see how we can deal with it. Okay, so now let's try this example also. A ship sails 24 kilometers from port A due south to point B. A ship sails 24 kilometers from port A due south to point B. It then sails due east from point B to a port C, a distance of 7 kilometers. Find the position of the port A from the port C. Okay, now let's look at this example. This is also Nathan. Let's look at it. Now, a ship sails, so this is the solution. This is the point A, the port A. So this is A. So 24 kilometers. So this is 24 kilometers. That's not drawn to scale. Okay. To point B. Then it then sails due east. So due east, we are going this direction. 7 kilometers. 7 kilometers. So 7 kilometers due east to the port C. So this is the port C. Please, for answering bearing questions, Normally, the sketch or the diagram that we are going to draw or to be drawn is not to the scale, but be mindful of the measurements. We know that 24 kilometers is definitely longer than 7 kilometers. So let's make it in this form so that we'll get the exact answer. We cannot say 24 and 7 are the same. So we make it in a way that somebody will be marking our answer will get the original answer, because when this is equal to, the length of this, what I've drawn here is the same as this one, there will be a problem. Okay, now we have to find the position of the port A from C. The port A from C. So let me join this. Okay, now we need this distance. Let me call it X. And then we also need the direction of A from C. So direction of A from C means we move from this point to this line in a clockwise direction. So that is going to be 90, 90, 90, 270 plus this angle here. Okay, so let me use the Pythagoras theorem to get my X, the distance AC first. So this is exactly right angle triangle. So this is my 90-degree symbol. So per what I've drawn here, line AC squared is equal to that of AB squared plus BC squared. Okay, so and AC has been indicated as X squared, and then AB is known to be 24 kilometers. So 24 squared plus 7 squared. So X squared becomes 24 squared is 576 plus 7 squared is 49. So we add the 2. This is X squared is going to be 625. Okay. So when you put square roots on both sides, we ignore the negative side. So that is going to be, X will be 25 kilometers. Okay. So it means that the distance between A and C is 25 kilometers. Now let's look at the bearing. Okay, so for the bearing, now let me call this small angle here theta. So from here to here is 270 degrees. Now 270 plus theta will give us the direction of A from C. Okay, so looking at this is opposite to, and this is adjacent, opposite to this angle. So I'm going to use tan theta is equal to opposite, that is 24 over adjacent, which is 7. So theta becomes tan inverse of 24 over 7. Okay, so theta will be 73.73 degrees. Okay, now we can say that theta is approximately equal to 74 degrees. Okay, now the bearing of A from C. The bearing of C from A is less than 180. So this is going to be, we take 180 from this one, or we can easily say that we find this and add it to 270. Okay, that is what even I said here. So the bearing of A from C becomes 74 degrees plus 270 degrees. So that is going to be 334 degrees. Okay, so the position of port A from C is 334 degrees. Okay, so thanks for watching. Please don't forget to subscribe, like and share this channel. We are Odum Maths is on YouTube, that is at Odum Maths 2134, and then on TikTok odum.maths, on Facebook Emmanuel Odum. See you in the next lesson. Bye.